Hey guys, this is your fellow maker Jugnu. You can also call me Jay if you like. In this video, I would like to share my learning and experiences while installing and configuring two cheap SD card add-on modules onto my MKS Gen L version 1.0 board. My board, which is set up for operation with the legacy mode TMC2208 stepper drivers, is installed on my Ender 3. I generally use Octoprint for all my 3D printing related activities, but needed an SD card slot for cases when the Octoprint interface is unavailable. Also, I had the requirement and a few requests to explore a much cheaper alternative for the MKS Gen L board in comparison to an expensive graphics LCD with an SD card slot. I'll be moving away from the Arduino IDE and exploring Visual Studio Code and PlatformIO IDE for this and upcoming projects. Hence, I'll be sharing my experiences in setting up and using these software tools while exploring the SD card related code space within Marlin's source code. So the first step would be to install and configure these two software tools. So let's kickstart the software installation by first downloading Visual Studio Code. You've guessed it, let's Google for Visual Studio Code. And follow this link which says download Visual Studio Code. And I'll choose to download the system installer in 64 bits for my machine architecture type. Choose to save and wait for the download to complete. Head on to the download location and double-click on the Visual Studio Code installer package to start the installation. Follow the installation instructions until it's completely installed. Let's launch Visual Studio Code. We'll now install the PlatformIO IDE extension. Navigate to View in the menu bar and select Command Palette. In the Command Palette's search box, type Install and scroll down to choose Extensions: Install Extensions. This will pop up the Extensions side panel. The same panel can also be invoked by clicking this icon in the sidebar on the left. Type PlatformIO in the search box and select this entry which reads PlatformIO IDE. Proceed to install this extension by clicking the green button labeled Install. Wait for the installation to complete as this will take a while. Once the installation is complete, hit the Reload Now button in the pop-up message box. Next, we are going to install the Atmel AVR platform. We do this by choosing the button name Platforms in the side panel of PlatformIO IDE's Home tab. Click on the button labeled Install Embedded Platform and choose Atmel AVR from the following list. Select from the drop-down the latest version and click on Install to begin installation. Installation would be complete once a pop-up message box indicates it as so. PlatformIO IDE is based around the PlatformIO command line interface. It is a utility which can be invoked through a terminal from within PlatformIO IDE. This utility allows us to configure and query various parameters such as the list of supported boards, connected devices, libraries, and etc. In Windows, unfortunately, it is not available right after installation. As can be seen, invoking it via the commands PIO or PlatformIO results in error. To remedy this, all we have to do is add the location of the commands' executable files to our path environment variable. In order to do this, we'll need to navigate into the C drive folder after closing Visual Studio Code. Head on into Users, then the folder with your username. In my case, it's Jugnu, followed by the folder .platformio. In this folder, navigate into the directory PENV and finally into Scripts. Copy the location address as text from the Explorer address bar. Now, in the search box on your Windows taskbar, type ENV in order to access the environment variables settings. Click the menu link to bring up the System Properties combo box. Choose the button Environment Variables near the bottom right. This opens up the Environment Variables settings box. From the User Variables panel, select Path and click on Edit followed by New. Right-click and paste the copied location into the new entry line. Click on OK until all the open combo boxes are closed. Let's relaunch Visual Studio Code. Navigate down to the bottom information panel and select the Terminal tab. Hit Enter to bring up the command prompt. Type PIO and observe that a help menu is now presented. Alternatively, typing PlatformIO gets us the same printout. With this, we have now completed the installation and setup of PlatformIO IDE. Next, we will verify our installation by building stock Marlin firmware. Retrieve a zipped archive copy of Marlin version 1.1.9 from the link provided in the description below. Unzip the sources into a suitable location and launch Visual Studio Code. In Visual Studio Code, click on the blue button named Open Folder or select File and then Open Folder. Navigate to the location where Marlin version 1.1.9 has been unzipped. For me, that will be in my Downloads directory, and I'll go ahead and select the folder Marlin-1.1.x. This will open Marlin firmware in PlatformIO IDE. Let's quickly perform a build test. First, we'll perform a clean of the sources by clicking on this icon which looks like a garbage bin. Once that's successfully done, click on this icon which looks like a check mark in the status bar. Wait for it to complete successfully as it will be indicated clearly. Now that our installation of the software has been verified, I'll proceed to make changes for my setup. My setup consists of the MKS Gen L version 1.0 board installed with the TMC2208 stepper driver modules operating in standalone mode, all attached to my Ender 3. The changes required are shown in detail in the video linked in the description below or as shown in the top right corner now. Have a watch if you have not or need a refresh, as I'll be going through this rather quickly. So the first change is to get stock Marlin firmware ready for the Ender 3. Locate your Marlin version 1.1.9 sources. Mine are located in my Downloads folder as shown. Navigate into Marlin-1.1.x, then Marlin, followed by example_configuration. Next, browse through Creality, and finally Ender 3. Copy all the files and head back up to the folder Marlin. Paste all the artifacts here while choosing to overwrite all the destination files. Next, open Marlin version 1.1.9 sources which were modified for Ender 3's use in the previous step. Browse for the file boards.h in the File View panel. Click on it for a quick view and scroll down until you find the definition for board_MKS Gen L. Select and copy this definition, then locate the file configuration.h. Double-click to open in edit mode and search for the keyword motherboard with the Ctrl+F. Select this definition which reads board_melz_creality and paste to replace it with our copied one. Finally, search for the keyword TMC, then select and copy this definition here which reads TMC2208_standalone. One of the nifty features of Visual Studio Code is multiple cursors. To use it, hold down the Alt key and select the definition A4988 for the X, Y, Z, and E0 lines. Press Ctrl+V to paste. Similarly, select the double slashes and hit delete to enable these lines. Ctrl+S to save our changes, and let's clean our sources before building by clicking this icon. Once that is done, proceed to click on the build icon and wait for the compilation to complete. Once the build succeeds without any problem, let's connect our board to our PC. Select the PlatformIO Home tab and click to choose the devices icon on the sidebar. This will give us a list of all connected COM ports. I only have one attached, which is COM3, so it will be chosen automatically. We can also view and select the COM ports by issuing the command pio device list in a new terminal. Choose the icon which looks like an arrowhead to begin upload. Wait for the upload to finish. This is one of the SD card modules which I'll be trying to install on my MKS Gen L board. This module is based on the SD-RAMS add-on module. What is the SD-RAMS module, you ask? Well, it's an add-on module to the infamous RAMS board which allows one to print off a micro SD card. Observe the pinout for the 2x5 socket as shown by the silk screen. This module is meant to be plugged into a 2x4 header located on the RAMS board labeled as AUX-3/SPI as shown. Similarly, the MKS Gen L version 1.0 board also has the same header labeled as AUX-3. The only difference is the connector on the MKS Gen L board is rotated by 180 degrees clockwise. As such, the module will plug into the MKS Gen L as so. Note the last two places on the module socket are left without any mating header pins. This is only meant to test the module, and a more permanent solution has to be found when it comes to the matter of mounting. Let's insert an SD card and then power on the printer. Click to access the main menu on the LCD and notice that no card whatsoever is detected. After searching on Google, I found a set of G-codes which are meant specifically for the management of SD cards. The one command which caught my attention was the M21 init SD card. This command can be issued to Marlin in order to initialize an SD card if it's not detected automatically. Now we'll be using another feature of PlatformIO IDE, which is the device monitor. I'll connect my printer to the PC and fire up Visual Studio Code. Navigate to Terminal and click New Terminal. Type PIO device list to see available devices. My device is listed as COM3. Type PIO device monitor -B 115200-echo and this launches a terminal connection to my printer. I'll send the G-code M21 and observe that I got a reply SD card OK. Let's check out if the SD card is available from the printer's LCD menu. Note now that it displays the menu item Print from SD and gives us the option to browse the card's contents. This is great as we now know that the module works. Type Ctrl+C to close the device monitor session. This simply means that we have to initialize the SD card before we can use it. Let's open Marlin version 1.1.9 from the previous step if it's not already open in Visual Studio Code. We'll be looking for the G-code command M21 to see how it's implemented. Let's conduct a search by selecting the magnifying glass icon on the Visual Studio Code's sidebar. Type M21 and hit enter to search. Notice we have a huge number of hits. We can see that a lot of the entries in the list are files configuration.h and configuration_adv.h from the example_configurations directory when we hover over the files. We aren't interested in these machine-specific files and we can use the advanced search feature to exclude this directory. Right-click on one such file and select Copy Path. Click on the ellipsis to expand the search details. In the Files to Exclude box, paste our copied path. Trim the ends until it reads marlin/example_configuration/ and add an asterisk right at the end next to the slash. Click to toggle the button at the very end of the box. Press enter to begin the filtered search. This is much better. Scroll down all the way until the file marlin_main.cpp and click to expand this list. I'm going to select the first entry as it seems relevant. This is just the documentation of the supported G-codes in Marlin. Let's continue our search for the next M21 statement. Click to open and this is what we were looking for. This is the implementation of the G-code command M21. It simply calls a function or method which is initSD. Quickly note that the search result instances which occurred specifically in this file for the keyword M21 are highlighted in the scroll bar for visualization and easy access. So now that we know this, let's search for the setup function. Why? Because an Arduino style program basically consists of the setup and loop functions. The setup function is responsible for configuring, setting up and initializing all hardware and software resources. Hardware resources here means the I/O pins, internal peripherals like timers and UARTs, and external peripherals such as LCDs. Example of software resources will be the many program variables, data structures, and user data in the form of constants like fonts, graphics, and tables. The setup function is meant to only run once right before the loop function, and it is intended to run quickly. The loop function is a section of code which runs over and over again endlessly. This is where the program spends more than 99% of its time. In a nutshell, the code here spends time checking flags and conditions which are set by internal and external events while reacting to triggered events by performing certain tasks. With that out the way, let's use another feature of Visual Studio Code, the Code Outline Explorer. Simply click on the Explorer icon which is on top of the search icon we used before. Collapse Marlin-1.1.x and this will extend the outline panel's height. Click on Outline if it's not already open. Scroll to find the setup function and click on it. Before going any further, note the name of the file in the tab is italicized, which means the file is open in preview mode. And as soon as we select another file, this tab will be used to preview that file instead. Double-clicking will change the file name font to normal instead of italics, which indicates it's now open in an editor. A file in preview mode will also open in edit mode if we were to make a change. Getting back to the setup function, notice the topmost comment tells us that this is Marlin's entry point. Scroll to look for anything related to SD card. Notice functions here tend to have words like setup, init, and start in their names. There we go, the last line of the function mentions SD support. And the following line does mention the word card. But the function is grayed out, meaning it is unavailable. Let's keep scrolling down and notice that we are going to enter the loop function. The comments tells us that this is Marlin's main program loop. Note the words SD support and card reappear as we scroll down some more. Let's check out yet another feature of Visual Studio Code. Click on the function Check Auto Start and then right-click to choose Peak Definition. This feature allows us to check the function's implementation without leaving our current file, which would be distracting as it breaks focus. From the comments, it seems this is a feature which allows auto-printing of files from an SD card. Also listed is where or when this function is called. Scrolling down, we finally get to init SD function, but it should have initialized our SD card if that's the case. Perhaps this guard condition disallows the entry of the program to this line. This guard condition exits the function if it is true. Within the peek window, double-click on the Check Auto Start function. This will open the file in a preview mode tab. Let's double-click on the first variable in the guard condition, namely autostart_index. This will highlight all instances of this variable in the scroll bar. Navigate to the topmost instance in the scroll bar and click on it. It seems the variable is initialized to -1. And the comment mentions that auto start will be disabled until card is initialized, meaning until the init SD function is not run or executed, the auto start feature will remain disabled. This also implies that the guard condition may well be true. Let's get back to check auto start function by selecting the next highlighted instance of the autostart_index variable from the scroll bar like so. Time to examine the guard condition. It reads, if autostart_index is less than 0 or SD printing is true, then return or exit from this function. With autostart_index set to -1 as we saw earlier, the guard condition comes into effect. With this, I have no choice but to hack the code and add the initialization by myself. Let's select the tab Marlin_main.cpp and scroll up to the end of the setup function. I'll be adding the following code. Firstly, let's copy the first part of line 15277 to a new line and hit enter followed by a tab. Type card followed by a dot and Visual Studio Code will offer all possible functions which can be applied to the variable or more specifically the object card. Another nifty feature, don't you think so? Select init SD from the drop-down list, then type open parentheses, then a close parenthesis followed immediately by a semicolon, and hit enter for a new line. Backspace and copy line 15279 to the current line. That is change number 1. For the next and final change, click line 15300 and press enter and tab twice. Go back to the file cardreader.cpp's preview tab and copy line 500. Note there's a white dot in Marlin_main.cpp's tab, which merely indicates that the file has changes which have not been saved. Select the File tab and paste on line 15301. Visual Studio Code will show syntax error with red wavy underlines. To fix this, all we have to do is type card followed by a dot after the exclamation mark and hit escape to ignore the completion suggestion box. Do the same for init_sd, meaning type card followed by a dot right in front of init_sd without any spaces. Go to the end of the line and add a new line. Ctrl+S to save our changes, and I'll do a clean and then a build before uploading the firmware to my printer. First, let's test the initialization in the setup function. I'll pop in an SD card before switching on my printer. Click to get to the main menu and we can see the option to print from SD. Let's check for the card's contents. And it works. I can see and scroll through the list of test files in the card. Next, let's switch the printer off and eject the card. Switch on again and notice that the boot up is taking much longer as seen from the LCD screen. The screen has become completely unresponsive. Button presses and knob turns doesn't trigger any sort of reaction whatsoever on the screen anymore. I'll have to admit my hack wasn't thought through very well. I'll probably have to design a better implementation. While thinking about that, I recalled something important. I have completely forgotten that on my stock Ender 3, from the LCD's main menu, I was presented with not only the option to initialize an SD card, but also to change one. This means I most likely don't have to implement anything, as it may have already been done so. With that, let's get back to Marlin_main.cpp and head on to the loop function to look for the LCD's event handler. Before doing that, we'll just comment out the changes we have made earlier. Select the block of code in the setup function and go to edit and choose toggle line comment. Do the same for the line of code in the loop function. Notice the block of comment for the loop function actually mentions an LCD update task. This is what we will be looking for. Scroll down to the very end of the loop routine. Select the idle task and right-click for Go to Definition. This is where the LCD update task is called. Select the function and right-click for its definition. Notice we get a peek window instead, as Visual Studio Code has found 2 entries for the LCD_update function. I'm going to select the highlighted definition, which resides in the file ultra_lcd.cpp with a double click. Let's observe the code structure from the Outline Explorer panel. Scroll down until we find the function declaration for LCD_main_menu and click on it. This is the declaration, and what we need is the implementation of this task. So let's right click on it and go to its definition. Perfect. Scroll down until we find the keyword SD support. This section of code basically is the menu items available on the LCD's main menu with regards to the SD card functionality. Basically, the first entry is the menu item, which gives the user the option to pause printing. Following that, we have the menu item to resume printing, while the next option is to stop printing. What we are interested in are the menu items which contain the string M21. We know that this is the G-code command to initialize an SD card. These are, however, grayed out, meaning that these menu options are unavailable in our current configuration. The comments indicate that this menu item is the user-initiated change SD card option, while the other one is the user-initiated initialize SD card menu item. Let's examine these closely. Observe the line right before each menu item has identical selection conditions. For this option to be available to us, we need this condition to be true. This condition translates to if the SD_detect pin is unavailable, then enable this menu item entry. You've guessed it, we'll need to look up for the SD_detect pin definition for our board. This means we'll need to open the pins configuration file specific to our board. Click on Marlin-1.1.x to access the file view panel. Scroll up until we find the file name pins_mks_gen_l.h and select it. Observe the file has no definition specific to the SD_detect pin. However, another file is included in this file right at the bottom. Right-click on the file name pins_ramps.h and go to its definition. Here, Ctrl+F to search for the keyword SD_detect, and this is the entry we are interested in. The pin is defined, which explains why the menu items were unavailable to us from the LCD. Copy the keyword SD_detect_pin and go back to File, pins_mks_gen_l.h by choosing it from the File View Explorer. On a new line after the last entry, type #UNDEF followed by a space and paste. Enter for another new line and type #define followed by a space and choose to paste again. Then immediately type another space followed by a -1, meaning we are saying this pin, that is the SD_detect pin, is unavailable, hence the user-initiated SD card menu items will be made available to us. Ctrl+S to save, and let's clean, build, and upload. Time for a test. I'll switch on my printer and then insert an SD card. Observe that now we get the menu item init SD card on the LCD. This is great. Let's initialize the card and then scroll for its contents. It works. Also notice we get the option to change SD card. Wonderful. Okay, let's now select to change the card. I'll pop out the card and insert another one. Let's select Print from SD and choose to refresh. And we see the contents of the other card as well. Wow, we have got this module working for us on our MKS Gen L board. Super nice. That wasn't the only SD card module that I tried. I also received this one sometime afterwards. Immediately notice the difference. That is, the previous module had a micro SD slot while this has a full SD card slot. Also, this comes with an 8-pin Dupont cable, which makes connection a whole lot more convenient. The link for this module as well as the previous one are given in the description below. This module, as seen, has no pinout whatsoever. Upon plugging in the module, I found that one of the IC got rather hot, even though I read in the forums that this module is supposedly plug and play. So the first thing to do was to compare it with the SD-RAMs module. We can see that the major IC components for this module are the same with the ones on the SD-RAMs in terms of functionality. This 3-legged IC is a 3.3 volts regulator labeled AMS1117, while the other one is a buffer or a line driver used to level shift the SPI signal. That is labeled 74HC4050. Both are linked below for reference. Observe the pin V-in from the pinout of the AMS1117 IC's datasheet. Using a multimeter, we can trace the supply pin's connection to the header and compare the position with the one on the SD ramps. We see that the input voltage is connected to the square pad, which is pin 1 or labeled as 5 volt on the SD ramps. Similarly, the ground pin is connected to pin 7 on the header, or also known as GND on the SD ramps. After some probing, the SD detect pin was found to be connected to pin 2 on the header, which is identified as D49 on the SD ramps. From this, we are able to fill in the relative positions of the other pins through comparison as shown. Observe the difference in orientation of the SD ramps connector both on the RAMS 1.4 and also the MKS Gen L board respectively. The 8-pin Dupont cable which came with the module, however, was not wired properly. The wires had to be rearranged in order to make the connection as shown. On the connector at the board side, lift the locking tab with a pair of tweezers and gently pull out the cable. Insert the correct wire into the connector, ensuring the mating indentation faces the locking tab. Push the locking tab down and verify that the wire is held in securely. On the cable which I got, all I needed to do was to switch the position of both the wires in each and every color pair. This may differ if you don't have the same exact Dupont cable as I do. In that case, all you have to do is to wire the connector as shown in the wiring diagram. With that done, plug in the connector and let's switch on the printer. Notice the LED lighting up immediately on power up. That's great as it behaves similarly to an SD-RAM's module. Let's first test it with the firmware where we have set the SD_detect_ pin to -1. We should expect the same functionality as we got from the previous module. Awesome! Now we'll comment out the two lines we added to the file pins_MKS_Gen_L.h in order to enable the SD_detect_ pin like so. Save, clean, build, and upload. Power on the printer and let's insert an SD card. The LCD shows a card inserted message. Let's pop out the card and now it shows card removed message. This is cool. Let's browse the contents for verification. Nice, now I'm going to quickly swap out the SD card for another. Browse for contents one more time, and it works. Excellent. Thanks for coming with me on this code excursion. In summary, at the end, we were able to connect and configure two inexpensive variations of the SD-RAM's add-on module to our MKS Gen L board attached to the Ender 3. The first module had no SD card insertion or removal detection, hence required only 2 lines of code change for the MKS Gen L board specifically. This module also required some mounting thought and effort, while the other module, which had the insertion and detection functionality, only required, in my case, a simple wiring change. In conclusion, I do prefer the latter module as it is easier in terms of mounting, and if I later choose to disable the insertion and detection functionality, all I need to do is to make the firmware changes required. With this, we have come to the end of the video. Enjoy and thanks again for watching.